Okay, you're also done with this one, definitely. Let's answer this one. Just to remind each other, TAN was given to be a tangent and also the fact that it is parallel to CB. If we have a tangent and we have something that is parallel, we can start using alternating, corresponding, co-interior as our reasons eventually. Theorem 7 is already knocked on our doors, and we also were given B1 to be 30 and D2 to be 51. So that was the given information. With that, I believe we can easily find A1, T, B2, and also C. Let's answer that one together. Right, for A1, let me emphasize the fact that we still have a tangent, this tangent, and there is this chord here, right there. So the angle we want happens to be at an angle between a tangent and chord AD. So you hold chord AD and you go with it to the circumference. As you can see, there is a 30-degree angle there. So you should also just write it as 30 degrees. This should then be 30. If that is 30, that should be 30. So that is A1. So you have noticed theorem 7 is, we usually use it quite a lot. So for the sake of time, I'm going to just write this in a straight line like this. Statement, reason, answer at the same time, and then our reason is tan chord theorem. Okay, so let's go to number 2. We want to find T. For this one, I'm sure you did it the same way. I want you to look at triangle. Look at triangle ADT. Look at it. Well, if you are looking at it, it means you're noticing how this 51 degrees happens to be an exterior angle of this little triangle here. So if it's an exterior angle, it should be equal to the sum of these two. So that is the statement we want to write first. So I want to need the statement. So let me write D2, look at it closely, is equal to A1 plus T. And this is because the exterior angle of a triangle is equal to the sum of opposite interior angles. Okay, that is the statement there. So let's put in the values that we know. This is 51 right here. A1 is 30 degrees and then plus T. I think you are noticing that if you want T, you just have to subtract 30 from 51. It should simply be 21 degrees. So let's put 21 degrees where we calculated it. That is the angle we just finished finding. Let's go. There is also question 3. B2. Now that's an interesting one. Where it is? I'm sure you also found that one. So look, we're now using our parallel lines. And I'm sure you're noticing there is a Z here, which we are not going to ignore at all. If we want B2, it should then be equal to, if you're looking at the Z that I'm talking about, it should be equal to that one. Those are alternating angles. So I'm going to write that statement so you can have it. B2 is equal to angle T. These ones are alternating angles. This is because TAN happens to be parallel to CB. We were given that already, so we could use the alternating angles easily. Right, so B2 will then be equal to 21 degrees as well. That's statement, reason, answer. Lastly, there is that number 4. We want to calculate C. C is just over here. It happens to be a part of either this triangle, or let's rather use the cyclic quad. The cyclic quad will work a bit faster for us, I should think. Here is our cyclic quad. As you can see, A and C will be opposite angles of a cyclic quad. So I'm going to write A plus C is equal to 180 degrees. And these are opposite angles of a cyclic quad. It's a cyclic quadrilateral. All four vertices are right on the circumference. Oh, notice how we don't have A. Did you see that A2 is not here? It's actually A2, this one, and C. So we are using A2, and at this point, we actually don't have A2. So I will have to just quickly calculate A2 now. You know, interior angles of a triangle, these two are adding up to 81. It means 99 should be left there. So A2 should be 99 degrees, sum of interior angles of a triangle. So if this is 99, definitely this one should be the remaining part of everything. It should be 81, I believe. Yeah. So C then, from here, you may have to say 99 plus C is equal to 180, meaning C itself is 81 degrees. That should be easy. All right, let's keep working it out. This is all for this question. Thank you. Let's go to another one.